1 2 3 1 2 3. Hello, hello, hello. This is a mic check 1 1 1. Hopefully you can hear me. If not, let me know. But if you can't hear me, you can't really let me know. And it seems that you can hear me. At least I can hear myself from the YouTube. So there should be some sound going out into the world. I would like to welcome you to another online webinar, online session. And this time I would like to talk about, and you can see the still image on your screens, about our SPI Lamp device, which is a signal splitter and output multiplier. Please, if you have any questions, I would like you to type them in the chat. And I will be more than happy to answer those as soon as possible. Once again, this will be about an SPI lamp device, a new design where we've added a couple of features. We've redesigned the PCB a little bit, so we changed the dimensions a little. And we also bring you some new features. We've got a 3D, we've got a file for your 3D printers if you would like a case for the device, since it is only a plain PCB, yet pretty powerful. So please, any questions, feel free to ask them in the chat. I've got a short presentation prepared, again, about the controller or about the device. So let's jump straight into it. Please, if you can't hear me properly or there is some echo or something, let me know and I will try to rectify it. I will just quickly check the stats. And it seems that everything is fine. All right. And we can go into the presentation. So this is an introduction event to our new device, SPI Lamp2. But first I would like to say a bit about our company, LED Strip Studio. We've got a motto: everything that you need for your LED pixel installation or projects you can find within or under a single roof. That is, under our roof. We are more than 15 years on the market, producing LED controllers and a lot of accessories and gadgets for your LED projects in order to make your installation process and the control of the content playing more fun, I would say. We develop, apart from the controllers, also our software. Current version is number 3, and you can use it as a content player for basically anything that you want to play on your LED pixels. It's pretty strong, robust. You can either use our custom protocol or ArtNet, for which you can buy a separate licenses that will last you for 1 year, and you can buy as many licenses that you need. We don't really limit you to how many pixels you can control with ArtNet. We are producer of LED controllers, both for your digital pixels and for analog. 3 main controllers that we are producing are LEC3 or LED Ethernet Controller 3, where you got a lifetime license for the software included with the controller. SPI Matrix, ArtNet to SPI converter. These 2 have 4 outputs for your pixels, and you can control up to 4096 digital RGB pixels. We've also got a small controller, a Reactivo 2, which is also a ArtNet to SPI converter. Great little device that you can hide really anywhere, and you can use advanced triggers to trigger the effects, sensors, buttons. Some of our previous webinars were actually about this very controller, so I suggest that if you are interested to find out more, go to our YouTube and find the 2 last webinars there. Also, we are producing small controller, SPI LED controller, which is not a network device, but it's rather a content player, so purely standalone controller where you create the effects within the software and then put them onto an SD card. We are located in Central Europe, Bratislava, Slovakia, so we are in the EU. Our main field of work, because we are not only producing the controllers, but we are also doing the projects installations, where in the past mostly TV studios, but we are also doing a lot of events. We are supplying and supporting a lot of artists for their projects, and we are also a company that is doing custom development for customers that need a specific device for their projects. A very short introduction about the company as it is. I just want to mention that we've got several channels where you can reach out to us whenever you have any questions. You can reach out to us on WhatsApp. You can send us a message on Facebook, Instagram, wherever you want. You can always call us, or you can book a free consultation over Zoom, where we can go very quickly through the project that you're planning, and we can suggest what might work for your specific project. So don't hesitate, book a slot, and we'll be more than happy to talk about your project. To the main topic of the event, of the webinar, what is an SPI lamp? I've already mentioned this. It is an output multiplier and a signal splitter. Now, what does an output multiplier means? With our devices, for example, with SPI Matrix, you've got 4 available outputs, and each can control 1024 pixels or up to 1024 pixels, but some projects require more than 4 outputs. And you can very easily use an SPI lamp to multiply the outputs that are available. So you can divide 1024 between 30 SPI lamps, and suddenly you've got 30 outputs available from a single output that is physically on the controller. Signal splitter, this feature is great for whenever you don't want to connect one end of the strip to another, because the signal travels from one SPI lamp to another, sends the portion of the data for the exact pixels, exact number of pixels connected onto an SPI lamp to your pixels, and then the rest is sent to another SPI lamp. So effectively, you don't have to connect the ends of the strips, because the signal is sent to another device. We are using, or the data that are sent from the controller to an SPI lamp are differential symmetrical data, so you can send it over a long distance. There is there is no problem to send the data on over 100 meters. We even tested 350 meters, but I would say that it is very important to test whenever you want to have such long runs of data cables. So first test it, and then make sure that it is actually working. But 100 meters will work fine, and as I've said, 350 meters we've tested and it was working. You've got with the SPI lamp a control along with our software over individual segments connected to each one of those SPI lamps. So you can set different animations, different colors, different effects to each and every single segment that is connected to your SPI lamp. We are not using ArtNet for the data transmission, but rather our own custom protocol that is used to send the data from the output to your SPI lamp. And it is also used when you are working with LEC3 controller to send the data from the software to the device. It is more compressed, and overall it is quicker than, let's say, ArtNet, broadcast over ArtNet, for example. So that is what is an SPI lamp. Any questions, please let me know. Why would you use an SPI lamp? I've basically explained this already. You can send the signal from one point to multiple segments. You don't have to connect the ends of the strips. So you don't have to follow the flow of the signal, because that signal is sent from one lamp to another. It greatly, in our opinion, reduces the cost of your installation of the whole process. You don't have to have so many man hours, in order to install everything, in order to connect everything with with additional cables, so you are using much less cables, and that means that people working on the project are working less hours. So that is saving up the cost, and it greatly, if planned properly and if the project is devised properly, then it can simplify the installation process, and it can make it much quicker. And as I've mentioned, whenever you want to send the data on a long range, which typically these days on the projects is every second installation, you can use the SPI lamp and you can send the data over a very long distance. These are the two controllers that you can use, the SPI lamp, and doesn't matter whether it is the first version or the second version. These two controllers you can use. So SPI matrix and LEC3 or LED Ethernet controller 3. And as I mentioned, we are using the custom protocol and we are sending out symmetrical data out of the output. So you can't use a Reactivo device or an SPI LED controller, which is the little white box, little white controller. These two, you can't really send out symmetrical data, differential data from the output, hence why you can't use the SPI lamp with these two devices. I would like to start, if there are no questions, which there are not, to show you the device actually, and what are the connectors available, and overall how the PCB looks and how it behaves, and what you can, what type of strips you can use with the controller. I've got one here on the table, but you can see also the ports on the picture in the presentation. Right now my face is going through one of the ports, so I can turn it off for a little bit. You can see that compared to the previous version, we've used different connectors for both the power and the output for your pixels. So now you can use the very same Phoenix connectors that you are using with LEC3 or SPI matrix for the output for the pixels, which is great because you don't have to, there is not a screw terminal block on the SPI lamp itself, but rather you can have that Phoenix connector where you will firstly screw in the wires and then you will connect it into your SPI lamp, and you can use wider diameter of the cabling, which is also great. And there is a second connector, only 2-pin connector for power, that you will introduce into the SPI lamp, and then you are also, or you can also power your strips through the LED output connector. So there is also a plus plus pin. Compared to the previous version, there are 4 pins, and yes, that is why you can, for example, send DMX from the output, or you can send again differential data from the output and connect multiple SPI lamps onto this port, but about that a little bit later. The voltage range of the SPI lamp is, as with all our devices, 5 to 24 volt, so pretty wide range of strips and pixels that you can use. The total throughput of the LED output is 5 amps. And you can use 0 to 1024 RGB pixels. If you would set RGBW, which you can, then it would limit you to only 768 RGBW pixels. There are 2 ports for the data. This is the data coming from the controller into the SPI lamp. And you can interchange the 2, so it doesn't really have to be, the port 1 doesn't have to be a input. You can use a port 2 as an input and then a port 1 as an output, so you can interchange the 2. Any questions? Not yet. Okay. There are a couple of status LEDs on the controller, on the SPI lamp, which can help you to find out the current status of the device. and it can also help you maybe debug if something is not going according to the plan. As you can see on the PCB, there are these 4 LEDs that are giving you information about the current status. Green one, obviously, this is for power. Whenever there is power present on an SPI lamp, the green one should be on. That way you know that you can connect your pixels or that the device has power. Orange LED means this one up here, that there is some data flowing into the device, and the red LED signals you that data is going out onto the port. Also, there are 2 small LEDs next to the ports, and these LEDs are on whenever the data, or it shows you from which port the data is going out. Also, there are some LEDs on a display, and these LEDs are showing you the flow of the signal, how it whether you used port 1 or port 2 as an input. So if you, for example, use port 1 as an input, these 4 LEDs will go from left to right, and you want to connect all additional SPI lamps in this manner. So you will, again, next SPI lamp, connect port 1 as an in and port 2 as an out. I will show you once I will play a test pattern from an SPI matrix. How does it look? So we can perhaps switch to this camera, and I can play a testing pattern. So red solid, for example. And you can see that all 4 SPI lamps, currently the status LEDs are on, and these 4 LEDs on the display are showing me the signal flow. So I know that I've used this port as an data in and this as an data out. If I will change these 2, then the little animation on the SPI lamp or on the display switched. So now the data goes like this, or you've used this as an in and this as an out. We can change these 2 back to a previous state. So right now I am playing that testing pattern from the web config, and I can go through red, green and blue. This is standard stuff, basically. Whenever, or if you already were working with an SPI matrix or LEC3, you know this web config environment. Here you've got all the settings in regards to your controller. The most important thing or most important setting whenever you work with SPI Lamp version 2 is to select a proper strip type from the menu. For the new version, you are always selecting LSS strip 2, RGB or RGBW. With a previous version of an SPI lamp, you were selecting these 2, but not anymore with SPI Lamp version 2. And obviously you can change the color order if needed. Are there any questions? Not yet, okay. And see, I've turned the testing pattern off. And there is only 1 LED on the SPI lamp currently on, and that is the green one. That means that the SPI lamp has power, but there is no data going into it because I have turned off the testing pattern and I don't have the software connected to my SPI matrix controller or LEC3 controller. And you can also see probably that the 2 LEDs next to the ports are blinking. That is, there is currently no, that is another way how to tell whether there is any signal going into the SPI lamp. When they are blinking, there is no data going in, so the device does not know which is in and out. So I can turn something on. So this is in regards to the status LEDs and those that are on the PCB and those that are also on the display. So this is a great way how to tell how the signal flows and how to, whenever you add more SPI lamps, continue with using the ports 1 and 2 for in and out, for data in and data out. So these were the status LEDs. There is also, which is one of the new features, we've also added a built-in display. With a previous version of SPI Lamp, you had to set the number of pixels connected to an output through the dip switch. We don't want to bother you with that anymore. That is why we've added a display. And there are a couple of settings that you can do with the display. So there are 3 or 4 menus available. You can set what is the IC used, so that is what is the strip type that you've connected to an output on SPI Lamp. You don't have to set that through a file that you upload through the device onto your SPI Lamp, although there is still this option available, meaning that if you have 100 SPI lamps and you want to set an IC on each and every one of those remotely and in bulk, you can still do this through the file, and you'll simply upload it onto an SD card and send it over through the output of the device onto multiple. But there is this built-in display, there is one menu, IC, and there you can set what is the strip type that you've used for this. Also, you can set up, I already mentioned this, how many LEDs there are connected, and it's also showing you what is the current voltage on power in onto the controller or onto the SPI lamp. So that way you can tell what is the voltage and whether you should or should not connect your LED pixel to it. Also, the information about the firmware version is available on the display. And I will show you quickly how does the settings on the display look. So you can see that although I'm playing the testing pattern, there are a couple of pixels missing, or a couple of pixels are not light up. So I can go into the menu on this SPI lamp, and I can go into the menu LED. I will confirm, yes, I want to go into this one, and I can increase the number of pixels. And if I will put the strip here, you can see that I'm increasing the number of pixels until I will reach the end of my segment connected to that specific lamp, and that way I can tell there are 29 pixels connected to it. I can go back into the menu, and now I know that I have set up this one specifically to this LED strip. If you want to set an IC, again, you will push any button, it will give you a IC menu, you will go into it, and there you can scroll through the ICs that are available. This one's effect for free, not a good IC selected, so I will go back in the menu onto IC2, which I know, as a matter of fact, is the correct one for this specific strip. By the way, I am using for the as a device for the output this version of an SPI matrix, which is instead of the Phoenix connectors, the green connectors on the back, using RJ45 for an output. And this is a version that we can supply to our customers on a request, and it's perfect for any projects where you know that you will be working with SPI lamps, since you don't have to produce your own connectors and your own cables. You will simply take an Ethernet cable and connect one output to your SPI lamp and you are good to go. So again, this is available on request whenever you are 100% sure that you will be working with SPI lamps. A downside is that you can't really power the strips through this type of connector. But in most cases, when you are taking the signal on a long distance, you've got the power supplies close to your strips, and you don't really to power it through the device, through the LED controller. So again, great feature for projects where you know you will be using SPI lamp. There's no questions here. And yes, and perhaps I can also show you the other two available menus in the SPI lamp on the built-in display. Right now, this one is showing the voltage that is on power in. So you can read that currently it has 11.7 volts. And you can do this on all SPI lamps. So I can go into this one and you can see that it's slightly lower than the one before. So this is the built-in display. Great feature. You can set the IC, the chip or the strip type that you are using, and you can set the number of pixels. You can check the firmware version, and also you can check the voltage that is present on the SPI lamp, and that way you won't power or you won't connect a 5-volt strip to your SPI lamp, because you can double check what is the actual power on the SPI lamp. What are the supported ICs, or what pixels you can use for the or with the SPI lamp? You can see this is a list of the supported ICs. Overall, there is something around 50, I think, because under one category there are multiple ICs. There are hidden multiple ICs. So if I will select this, the second, and all these are supported under this ID, under this index of the IC. You can use standard TM or WS family pixels, and yeah, overall RGB and RGBW, of course. Just keep in mind that then you are limiting the number of available pixels from 1024 to only 768. But if you like RGBW, then you can still use an SPI lamp. What is very new with this new version of the gadget is that you can send out from the output, similarly to LEC3 or SPI Matrix, VMX data. So you can connect your dimmer to an output of SPI lamp, and you can that way control your analog pixels. And you can combine digital and analog, or you can use SPI lamp only for analog pixels, which is a great feature, something that was requested many times with the previous version of the SPI lamp. And after the redesign, we've upgraded this new version so that you can also use it for VMX dimmers, and you can use analog pixels, which is a great feature. And also what you can do is you can use the custom protocol, the LSS protocol 2, on the output of the SPI lamp, and that way you can connect more SPI lamps onto the output of a single SPI lamp, and that way you can build this tree-like structure. You don't have to go linearly from one SPI lamp to another, but you can have a line of SPI lamps, and to one you will onto the output connect your another SPI lamp. So basically you can build a tree-like signal structure, which is also a pretty great feature, which was not available previously with SPI Lamp, but with this new version there is such an option, which we are super happy about. If there are any projects where you would like to use this feature, reach out to us and we'll be more than happy to help you with that. And yeah, overall we think it's a great little feature. It seems I have this 2 times here. Okay. I wanted to, if there are no questions still, it seems that there are not, I want to show you the two examples that I was talking about before. Who put me on there? So I've got this DMX dimmer. This is also our device. And I've got a 12-volt strip, 4-channel dimmer. Here. So this is a 4-channel dimmer. We call it lady dimmer. You can connect your analog pixels to it. And I wanted to show you how to connect your analog pixels. I've got this cable prepared here. So you can see this is a simple Cat5 cable that I've adjusted so that I can use it for the output of the SPI lamp. I can use this one. And as an input, because we are using RJ45 ports on the lady dimmer, as an input for the DMX data. So I will check what IC I should select. That I can check in the table. You can see that I have to select index 17 for this SPI lamp in order to connect my dimmer onto it. So 16. It's this one. IC, select, and it should be 16, no, 17. And that way it should output DMX data. And play the testing pattern from the web config that I have turned on. Maybe we can change this to only red dimming, so that way it is better. It's visible better. So once again, great feature that was requested many times by our customers. They wanted to use their analog dimmers along with some digital pixels, and they wanted to use an SPI lamp with this, and it's finally here, so hopefully it will be an interesting feature for your projects. Apart from the DMX being able to send onto the output, you can also send out LSS2 protocol and create this tree-like signal structure. And for that, you have to select again a proper IC, as always with the controllers. So you can again, or we can again check the IC which we should select. And for LSS strip to RGB, we should select 33 as an IC. So we can take this away, turn it off. Go into the menu again, IC 33. And we can, for example, take this SPI lamp and send from the output onto my SPI lamp the data. You can see that there are currently not all LEDs on. That is because you have to set on that SPI lamp that you are connecting, or where you are using the output and sending out the LSS protocol. On that very SPI lamp, you have to set how many pixels you have connected after that SPI lamp. You can see that the signal is still going into my next SPI lamp. Yeah, so it's going from the output into my first SPI lamp, playing the testing pattern, then into my second SPI lamp, sending the testing pattern to this one, and also sending the testing pattern onto the LED output of the SPI lamp. But I have to set how many pixels are there on this SPI lamp. So I will go into the IC LED and set. Can you put this into detail? How many pixels I have connected there. Until I will reach the end of the segment. I only have one segment connected here, or one SPI lamp. If I would have another SPI lamp connected to this one, and you want to continue with more SPI lamps, then the total number of pixels connected to those SPI lamps, those segments, has to be set on this one, on the one from where you are splitting the signal. That is, it's not going only to the second port, or the one that you are using for an out, but also on the LED out. Yeah, so it's very important that you set the correct number on this SPI lamp. We can change the pattern. So for example, we will use a color snake, and you can check that the animation is going as it is intended. So this is again a great feature which can help you achieve or build even more interesting projects even more easily, because you are not only limited to connect to the connection of your SPI lamps in a line one by one, but you can have a line of SPI lamps, and from one SPI lamp you can output the data into multiple SPI lamps connected only to that single one. A tree diagram is something that can perhaps best explain this very feature. In addition to DMX, you've got also this option. Hopefully it will be an interesting idea for you. This is it for the introduction of the SPI lamp. If you want to work with our software and SPI lamp, then you would follow the very same process as with the first version. You will create multiple digital pixels, multiple segments, and those you will put into a group. I've got, I think, a simple mapping. Just stop the test. So see, I've got this simple mapping, but again, this is a topic that was covered multiple times in the past, so go check our YouTube for the tutorial on how to work with the SPI lamp and the LED Studio software. Very briefly, you will create 3 segments. I have 4 SPI lamps, but only 3 segments connected to it, 3 pixel segments. So you will create 3 LED pixels, and then you will add them one by one into a group. Group means group 1 is output 1. If you will use multiple outputs, then you will have multiple digital strips and multiple groups. Each group is a specific output. So the process is basically the same as with the previous version. And the only exception is whenever you are using a DMX dimmer, you will add a digital strip, assign it to a group, that means to a specific output, and you will not set the, in the setting curve LED, you will not set the number of pixels that are connected there, but you will only set this to 1, because with analog strips you can't control segments separately. You are controlling only the whole strip, whole segment that is connected to your dimmer. So that is the only exception on how you will create the mapping in the LED Strip Studio software whenever you will use an SPI lamp and a DMX on an output. And that way you can, from the software, play an effect onto both your digital and analog pixels. So this is it for the software. Once again, if you want to check the details on how to work with the software, go to our YouTube and find out there the tutorials. Or if you don't know where to find them, or you're too lazy to find them, let us know and we will send you a link where you can find more information. As always, you can find a lot of information actually in a support section of our page, where there is this wiki available with a search available, and you can type in what device you want to work with, and or with what settings you are struggling with, and you can find a blog about that very topic, and you can follow the instructions there. I wanted to also show you in the shop section of the page, you can find the SPI lamp splitter, and there in additional information you can find the files for you to print the box on a 3D printer. This is that box without the top cover. There are 3 files within the file that you can download on the page, which will print the bottom, the top, and the little buttons. And yeah, it's available for free on this very page for you to download it and print as many boxes as you want or as you need for the project. On request, we can also supply the boxes. So if you need, you don't have an option to print them yourselves and you want us to deliver those, let us know, and on request we can also print the boxes. And if you want to expand on the design or create your own, feel free to use the files that are available on download and create your own box. Just don't forget to send us what you've created, so that we can share it with the world. All the information, the data sheet, you can find also on this very page, where you can find all the information about the gadget, and also the pinout schemes, how you should connect your LED pixels to the output. And there is also a manual available, where you can find, for example, the scheme for the connection, for that tree-like connection, or a typical connection. Again, a lot of information. Basically everything that I have put into the presentation you can find here, and that manual is also available for download in a eShop in the additional information section. I think that's it for this short webinar. We are on already for 46 minutes. which is 1 minute overdue or more than I wanted to spend on this. Hopefully it was an interesting webinar for you. Hopefully the information was enough, that I've explained everything properly and correctly. If you will have any questions, feel free to contact us. If you want to discuss your project, go into this very section on the page and book a consultation, and we'll be more than happy to talk about your project. Thanks again for joining, and since there are no questions, I would like to thank you again for joining, and I will see you on some next webinar about some next topic. Have a good day, and see you later. Bye.